This is paper 2 of grand test examination, online grand test examination conducted on 10th April. Please try to see. There are a lot of easy questions in this. Now you take the first question. A horizontal tube of uniform cross-sectional area A is bent in the form of a U tube shown in the figure. Liquid, you see, there is an entry point, there is an exit point. As a result, there is a thrust. And what is he asking is, what is the force required? My point is very clear in this. What is my point in this? What entry and exit, right? See, for example, if I assume that dm by dt is the mass per second entering, see that particular part is having a momentum of dm by dt v rightwards initially, finally dm by dt v leftwards. The change rate of change of momentum is 2 times dm by dt v. dm by dt, you know, equation of continuity, rho av. So using that, you will have rho av 2v square. This should be a correct answer question. No one should miss such a question. Next, 19th question. Here, I think this is the most comfortable question for you. How come it is a most comfortable question? Very simple. You know, a sample goes down to 6% in a time of 2 hours. It is as same as the situation is as same as you know, 6 by 100 is, I think you know this relation, no? 1 by 2 times given time by half lives. I think in chemistry also you would have gone through 1 by 2 times t by number t by t half gives a number of half lives. 6 by 200, right? You want a half life period, right? The activity of a radius has go to about 6% in a time of 2 hours. Right. So what I can do is 2 to the power of t by half life. This is one way of solving. Let me choose other way. What is the other way? A is equal to a naught e to the power of minus lambda t. E power lambda t is equal to a naught by a, which is 100 by 6. Now take a logarithm on both the sides. What is the logarithm on both the sides? Lambda t is equal to natural logarithm of 100 by 6. So, right, in a time of 2 hours, lambda is log e 100 by 6 by 2. Hold on. Now, what is that you want is natural logarithm of 2 by lambda. That is half-life formula. So, natural logarithm of 2 by lambda, which you can write it as log e 100 by 6 by 2. Means this can be written as a log e 4 by log e 100 by 6. You need to solve this. Log m by log n. Any, can we modify this by any form? Can we write it as no? In that way, you cannot write. So this we need to solve. That is one way of doing the question. But the other way is if you can convert into minutes, if you see that there is any benefit, that also you work. Because they are asking answer in minutes. So that also you need to work. Where that gets affected, 100 by 6 in 2 hours. This two part gets affected. This two part gets affected. This two part gets affected. So you cannot write it in this format. Then what happens is that 2 times natural logarithm of E2 by log E100 minus log E6. So the calculation of which gives you, as per their answer, it is a 30. And you need to, I think, minutes, you need to, hours, you need to convert into minutes. This works around some 120 actually. 120 into natural logarithm of 2 by Natural logarithm of 100 minus log e 6. We'll come to this later. Cause should not waste time on one such question. 20. A planet of mass m is revolving in an elliptical orbit around the sun with an orbital speed of t. Orbital period of t. If m be the mass of sun and a be the area of the orbit, then the angular momentum of the planet is. And there is a relation for rate second law, Kepler second law, dA by dt. Aerial velocity is given as L by 2 times m. The area covered is A and one time period is T, L by 2m. So therefore, L is 2ma by T. It's such an easy question, you see. You don't find such easy questions often in IIT question papers. Easy question, you should not miss this. Right. Next question. Figure shows a thin metallic sheet lying in y is equal to 0 for which a current of constant density flows. Fine. In a positive x direction. Fine. Okay, no issues. It is immersed in a constant. First of all, forget about uniform magnetic field. Forget about that. If we have such a sheet, carrying current like this is outward current. Due to the conductor, you will have fields like this. And that BC is given as mu naught I by 2. Apply amperes, I will get this. Otherwise, in my notes, I have done this. I stands for current per unit length, not current. Now, issue is there is it is immersed in a uniform constant field. Means if this is the conductor, already you have fields like this. B naught. B naught. Next, you have fields like this. B naught plus BC is the field here, which you have given it as B1. B naught minus BC is given as B2. Sir, how do you know it is B naught minus BC? Look, net field is upwards, but flux is less because it is a difference of two quantities. So therefore, you take the sum is going to be 2B naught, which is going to be B1 plus B2. Done. B is the answer. Simple question. Very simple question. You should not miss this. Right. Next, 22. There is a thermodynamic cycle in a PV diagram. It is a PV diagram. Already in the first paper, there is a PV diagram. This is a second PV diagram. Performed by 1 mole of a monatomic gas. 1 mole of a monatomic gas. The temperature at A is a T naught. Remember, it is passing through the origin. Please see that it is passing through the origin. Means PV is actually PV is proportional to T. You know that. But this is P by V. So what do P by V? That's that. It's P proportional to V. So what do P by V gives to you? That you need to follow. We know PV proportional to T, but this is P proportional to V. Actually, A, B, if you see, temperature of B obviously be greater than temperature of A because it is away from the origin. Right? No issues. See, in such a question, what is that you need to work on is a multi-correct answer type. Right. The temperature at A is T naught and the volumes are related VB, VC. If this is V naught, VB, VC is 2V naught. If this is P naught, since volume is doubled, it this is because it is a straight line, P proportional to V. This should be 2P naught. Right. The maximum temperature during the cycle is 4T naught. True. Because at B, the product is 2P naught, 2V naught. 4P naught, V naught. Are P naught, V naught, if it is proportional to T naught, 4P naught, V naught is proportional to 4T naught. At least I can do this question. Net work done by the gas during the cycle is no issues. Area of the triangle, half into base into height. Half into 1 mole of a gas, N into RT naught. N is 1. So this is RT naught by 2. At least I can do this. At least I can do this. Heat capacity of the process AB. अरे यार अभी अभी बोला मैंने. P proportional to V is the process AB. So PV power minus 1 is a constant for the process AB. So therefore, molar heat capacity is CV plus R by 1 minus X. 3 by 2 R plus R by 1 minus 1. This is a 3R by 2 plus R by 2. 4R by 2, 2R. C is equal to 2R. Correct. Efficiency of the, very simple. Efficiency means heat taken is happening only during AB process. Work already I have calculated. So efficiency is work by heat taken in. Work already I have calculated. That becomes 0.5 RT naught. 0.5 RT naught. Heat taken. अरे यार अभी you have molar heat specific heat C. Hello. And NC delta T. You already said the temperature at B is 4T naught. The temperature here is T naught. N is 1. C is 2R. 1 into 2R into 4T naught minus T naught, which is 3T naught, which is 6RT naught. 6RT naught. So what is efficiency now? 1 by 12 percentage. 100 by 12. That gives you 8.33 if I am not mistaken. Right. Otherwise, I'm very comfortable in the first three options. Any doubts? ఏదిరా నాకు ఒక్కసారి ఏది 3T naught ఇదే వెరీ సింపుల్. ఇక్కడ టెంపరేచర్ 4T naught. ఇక్కడ టెంపరేచర్ T naught. Molar heat, specific heat of the process AB is 2R. What is the formula for the NC delta T? That's how I got 3T naught. అవును హీట్ కేవలం A to B నే తీసుకుంటే B to C rejected. Isochoric process rejected. C to A heat rejected. So what is the efficiency of the cycle? Work by heat taken in. Heat is taken only during the process A to B. Right. Till this point, you can do. I'm telling you again. Next, the plates of a parallel plate capacitor with no dielectric in between are connected to a voltage source. Now a dielectric constant K is inserted to fill the whole space between the plates with the voltage connection on. Remember, voltage connection is still on. Potential drop remains the same. That is the first observation. Next, what happens thereafter? Energy stored is half kCV square, which is same as K times U naught. Energy increases by K times. The electric field inside the capacitor will decrease to K times the initial field. Wrong, because you have the same potential difference across the plates even now. Same potential difference by distance between the plates is still the same. So therefore electric field is the same again. Next, the force of, I told you very clear. The force of attraction between the plates will become K square times the initial time. Remember, you may question me, sir, you told Q square by TC. Yes, previously charge is Q. Now the charge on each plate is KQ. It is proportional to Q square, F proportional to Q square. Now, initially Q square, finally KQ times square. So it is a K square times the initial value. Absolutely correct. The charge, come on man, option D already answered. This is an easy question. Do you still find any doubt? అరే నేను కేవలం నీ ఒక్కడి గురించే పేపర్ డిస్కషన్ చేస్తాను తెలుసా, ఎవరికి నేను చెప్పను మామూలుగా అయితే. ఎందుకంటే నేను ఒక్కడు నా పేరు చెప్పుకొని బాగుపడ్డా అది నాకు సంతోషాన్ని ఇస్తుంది. నువ్వు నిజాయితీగా ఉంటావు. అండ్ దిస్ ఈజ్ రికార్డెడ్ ఇన్ ఇయర్. ఐ కెనాట్ ఎడిట్. రైట్, ఎనీ డౌట్స్? గుడ్ క్వశ్చన్. ఇప్పుడు వితౌట్ ద కనెక్షన్ ఆఫ్ బ్యాటరీ, already 2 plates are charged. That's all. It is not connected to the battery. And you have inserted dielectric. I said what? Even now force is 2 square by 2c. What is Q? Charge on the each plate. What is the charge on each plate now? It's no longer Q. It is a KQ. Right. Right. Next. Remember, I'll take this later because seeing there are worst numbers in that. So it might take some calculation because I'm writing exam now. In an LCR circuit, resonant frequency is 600 Hz and half power points are 652 Hz and 550 Hz. In this, if you know formula, it is done. What is, you may ask, sir, it is out of syllabus. Wrong. It is out of syllabus in mains, not in advance. So what is the formula for quality factor? Quality factor formula Q is equal to resonance frequency by 2 times delta omega. Resonance frequency is 600, 2 into difference 652 minus 552. How much is that? 100. 100. The quality factor is omega naught by 2 delta omega, right? Actually, it should be 3, no? But they are given actually 6. Wrong. Yeah, actually 1 minute. I'll explain you what is 2 delta omega. This is called delta omega. Now 600 and 652. What is the difference? 52. 2 times 52. So nearly this is 100. 52 nahi actually, right. Nearly. So therefore nearly this is 6. Nearly, not exactly. Right. Andakani you said 2 delta omega. Right. Do you remember this question? I told you someday in your grand test you will get this Pathfinder question. I don't know, you are giving me a first question. Indu, am I right or not? Did I show this question earlier, 2 days back? Yes or no? Did you solve this in the exam? Sure? Very good. Simple question actually. I marked that you will definitely get this question. Now what is happening in zero gravity? A drop of liquid of surface tension sigma assumes a cylindrical shape of diameter d between 2 parallel plates that are a distance d apart. If the curved surface of the drop is at right angles to the plate as shown in the figure, and force exerted by the drop on the plate is pi sigma d by n, then find n. Actually, it is a cylindrical drop. So actually, this is how the drop is. So what is the excess pressure inside? The excess pressure inside is surface tension times 1 by R1 plus 1 by R2. You know this formula. Different radius of curvatures. Sigma, what is the radius of curvature of this? Already you said diameter D. Diameter D, right? So D by 2 is the radius. What is the radius of curvature of the other? See, if you see from the top, you need to take one curvature like this, other curvature like this. They are parallel lines. There is no, if it is a sphere, you will have arrangement like this. Here you will have one curvature, here you have another curvature. But whereas it is a cylinder, one side you will have radius of curvature R, D by 2, the other it is infinite, plane. So therefore 1 by infinite. So you are getting 2 sigma by capital D, right? But 2 sigma by T is excess pressure. Force exerted by the drop on the plate, excess pressure. I got excess pressure. And what else you require? Force is into area, pi d square by 4. 2 sigma by D times, hold on, pi d square by 4. dd cancel. 2 like this. Sigma pi d by 2. Answer is 2. Pathfinder question. A simple question. I told you will definitely have this question. Next. 27. A parallel beam of light is incident. We need to do. I can do. Is incident from air at an angle of alpha on the sides PQ right of a right angled triangular prism whose refractive index is √2. Light undergoes total internal reflection in the prism at the face PR when alpha has a minimum value of 45 degrees. The angle theta of the prism is n times 3 degrees. Then find n. Please try to understand what exactly happens in the diagram. Ray goes like this, and it is undergoing total internal reflection. Means this will become R2 actually, and this will become R1. So what is that? We know earlier R1 plus R2 is A, but this is a different R2. Remember, we know if the ray enters like this, you will add R1 plus R2 as A. But in this case, it is not like that. You should take R2 minus R1. Right. So otherwise also, I don't think it is not it's not a much a debatable thing, because I don't I'm not sufficient. That diagram is not sufficient for me to handle. There some rough is required. Right. Now I am taking a different color. Here, this is alpha. And this is R1. You know, this is a theta. This is a 90 minus theta. This part is 90 minus a theta. Agreed? Right. I'm not dealing anything related to optics. I'm just dealing with geometry. And I know this is R2. Remember, this will become 90 minus R2. Remember, what is going to be this angle? 90 plus theta. So 90 plus theta plus R1 plus 90 minus R2 is 180. So therefore, theta is R2 minus R1. That's what I have. R2 is 45 degrees. Right or not? Alpha has a minimum value of 45 degrees. Okay, 1 sine 45 is √2 sine R1. Boss, R1 is 30 degrees. Right. You want theta. R2. What about R2? 45 degrees. Are critical angle sine inverse 1 by √2. So therefore, 45 degrees. So 45 degrees minus 30 degrees is 15 degrees. You said 3 times x is 15 degrees. That should be 5. Answer is absolutely correct. Right. Any doubts? Next. A wire having a length L and cross-sectional area E is suspended at one of its ends from a ceiling. Density, Young's modulus of the wire and are rho and y respectively. Actually, you should remember this formula. It is a strain energy due to its own weight. Repeatedly, you will have this. But right now, if I say that you should remember, you won't accept. I know. This is the wire, for example. let this be some y, and this is some element. The tension in that element is mass per unit length lambda g L minus y, mg by cross sectional area. What is cross sectional area? A. Remember, this is stress. Energy stored is half into one is stress into strain into volume. The other stress square by Young's modulus. Stress square by Young's modulus into volume A dx dy. Otherwise, don't confuse between this way and that way. Capital Y is Young's modulus, small y is the distance. So which means A by y, A by 2y, stress square lambda square g square by A square times L square plus y square minus 2ly dy 0 to L. Therefore, A by 2y or something else also we can bring this out, A square. And finally, what will happen is L cube by 3, L cube only, not L cube by 3, plus L cube by 3 minus L cube. After doing integration, please don't ask me those intervals, for God's sake. Next. Right. So therefore, A by 2y, lambda square, all this solving, lambda square L square G square L by 3 A square. You can write this as finally, or here, what is that you have given? Density. Okay, no, right now I'll write m square G square L by 6 A square Y. Or here they're asking the denominator number. 6 ho gaya na? That's all. But you should remember this relation. M square G square L by 6 A square Y. Elongation due to its own weight. Next. In a hypothetical system, a particle of mass m and charge minus 3q is moving around a very heavy particle having charge q1. Heavy particle. What is the meaning of this? The basic understanding is that it is not reduced in mass case. The center of mass lies at the center only. Assuming Bohr's theory to be applicable to the system, the orbital velocity of the particle when it is nearest to the heavy particle is the orbital velocity of the particle when it is nearest to the heavy particle is 3q square by x epsilon naught h. If you am assuming Bohr's theory, I should assume that it is moving in circular orbit. Right, no issues. So one thing is clear. 1 by 4 pi epsilon naught 3q q1 by when is it nearest r square is mv square by r. R cancel. So v orbital is that is one part. V orbital is, so I got radius, that's what I can say. 3q q1 by 4 pi epsilon naught mv square. I got radius right now. MVR is equal to NH by 2 pi. That is another part. So V is the orbital velocity actually. M V R can be written as 3Q Q1 by 4 pi epsilon naught M V square is H by 2 pi, because nearest means N is equal to 1. Therefore, V is 3Q Q1. अरे यार ये 2 times होगा, 2 epsilon naught H. Please confirm whether my observation is correct or not. మరి ఇందులో ఏమో Q minus 3Q Q అయి ఉండాలి అది. Otherwise, how can I solve that? So I am assuming it as a 3Q square by 2 epsilon naught H. My answer is a 2. Absolutely correct. Right. So I am confused with Q1. Actually, it was mentioned as a Q1. In the final process, that took as Q1 as Q. Right. How to judge? Answer. Right. Particle of radius, 1 minute. Let me just see. Okay, right. As a cylinder of radius 0.1 meter and mass 2 kg is placed such that it is in contact simultaneously with the vertical and horizontal surface as shown in the figure. The coefficient of static friction is also given. Distance T in centimeter from the center of the sphere at which F is equal to 40 Newton should be applied so that the cylinder just starts rotating in anti-clockwise direction. The problem here is the contact surfaces are friction. So suppose in this case, if this is the tendency of rotation, for example, what is happening is that at this point, the friction direction is like this. I am assuming this as mu N2 and this is N2. By the way, there is a normal reaction force here also, N1. And remember, on this, friction is directed upwards, and that is mu N1. By the way, N1 is mu N2. And what about N2? Hold on. What are the downward forces? F, weight, are downward forces. N2, mu N1, upward forces. 1, 2. 2 steps I have. What are unknowns? N1 is an unknown. N2 is an unknown. Okay. D is an unknown again. So in this, now take center as a criteria. Apply torque equation about the center. Fortunately, your normal reactions pass through the center. So you don't need to count the torque effects of those. But friction contributes some torque. Should consider that. So therefore, F into D minus mu N2 into R minus mu N1 into R is I alpha, equation 3. So solving this, you have 3 unknowns, N1, N2, D. So just starts means even you can take alpha as 0, no issues. Just starts means F into D is mu N2 R plus mu N1 R. Just starts. Done. Okay. Now you solve these 3 equations, you'll get the answer. Hold on. I need to stop this. Time అయిపోయింది, అది ప్రాబ్లం. నేను అప్పుడే. So as mentioned, by properly doing all these calculations, you will get the answer as a 6 for this. Value of D you will get as a 6. Okay, right. See, both are simple questions actually. Not much of calculations are involved. But only thing that you need to know is how to handle two wave pulses are traveling in the opposite direction with speed 1 meter per second because it's the same medium. So you will have same speed. Figure shows the shape of the pulse at t is equal to 0. Based on the above facts, answer the following. You can see that there are two triangular waves. One of which is of the width 4 meters. The other is of width only 2 meters. How do I know? 14 to 16 is only 2. The speed of the particle in meters per second at x is equal to 2 centimeter and t is equal to 0 is. At least you can answer first question. How? Speed of the particle is dou y by dou x times speed of the wave a minus tau. Since they are asking speed, there is nothing to worry about the sign. Please try to understand at least one option you can work. Where is x is equal to 2? Here. You need to take the slope at that point. What is the slope? 10 mm by 10 mm by 4 centimeters. Into velocity of the wave 1. 0.25 meter per second. Now, what is the displacement of the particle at x is equal to 8 centimeter and t is equal to 0.06 seconds? First, at t is equal to 0.06 seconds, what is going to be the fate of this is a 2, this is a 4, this is a 6, this is a 8, 10, 12, 14, array meer na చెప్పేదంటల్లా 16. Anish garu. Right. Yet 6 seconds, where exactly you are? You will shift. This entire triangle is at 4. You are traveling with 1 meter per second. Means 100 centimeters per second. In 6 seconds, where you will be? This one will be at location 4 plus 6. Come on, boss. 4, akkadi nunchi 6. Means this line is at 10. Which means your wave pulse changing the color. Same color. That's the picture. The one which goes in the forward direction. But this is also going in backward direction at a speed of 100 centimeters per second in 0.06. From here, add 14 minus 6. So where is this line posted at? 2, 4, 6 means at that instant, I'll change the color. Okay, right? You will have అంతే కదా 6 means and that is only 2. At the same instant, due to this, it is a 5 mm and due to this, minus 5 mm. The one which is at x is equal to 8 centimeters. Cancel. Resultant is 0. Answer 0. I don't even do a single calculation in this question. Just applied concept. Next question. As it is previous IIT question. There's no change in that. Only thing is there is a multi-correct answer type question. This is given as a truncated call. A small block of mass m is equal to 1 kg is placed over a wedge of mass m is equal to 4 kg as shown in the figure. Mass m is released from rest. All the surfaces are smooth and the origin O is fixed on the ground as shown. Based on this, information, answer the following. Now, see, please try to understand by the time the block arrives ground. Okay. So with respect to the plank, displacement of the plank is minus small m by capital M plus small m times displacement of the block with respect to plank. Minus 1 by 5 displacement 4. You can see this is minus 4 by 5, which is 0.8. 0.8 meter. Which means by the time the block reaches this end, this front end is at a location 0.8 meters from the origin. From the origin. Got it. Here is your origin. And this block is at a distance of 0.8 meter. And what exactly it is? 4 by 5, 0.8. What exactly this is going to be? 3.2 meter. Yes or no? And this is having some velocity v. Right. I want to find that velocity right now. And see loss in potential energy. Mu relative again. Mu relative mu means 4 into 1 by 4 plus 1 5 and relative velocity capital V plus small v square is m 1 kg into g into 2. 2. So capital V plus small v square is 5 into g 50. Capital V plus small v is root 50. Hold on. Momentum is conserved along the x direction. So therefore, 4 times capital V is 1 times small v. So in the place of capital V, I will write V by 4. This will become 5V by 4 is root 50. So V is root 50 times 4 by 5. All this is fine. What does the exact one? Find the velocity of the wedge in meters per second. I've done. You want V by 4. So root 50 by 25 actually. I 5 को root में ले लिया. This will become root 2, which is 1.414. Absolutely correct. The block strikes the x-axis. Right. No. 1 minute. You need small v right now. Again, it is a root 2 times 4 or 4 root 2. Fine. At what point it will strike? Right. It will strike somewhere over here. From here, I will take the formula as a range. The answer is 3.2 plus range. 3.2 plus range means range formula for horizontal V times root 2h by g. Hold on. 3.2 plus V 4 root 2 into root 2 into boss. What is h? 2 by 10. You do whatever you want to solve this. 3.2 plus. Just solve this here. Bus. Yes, please solve this. Find the block strikes the x-axis at some point. Just solve this. Right. So I have done all these, done. 1 minute. This is one question left. My goodness, only one question. అంతేగా ఇప్పుడు నేను ఎక్కువ టెస్ట్ చూస్తారు ఎవరన్నా ఒక That's all. Only one question. right? Again, I have done, this is 1250, adjustments are there. You should consider all that, right? In a resonance tube experiment to determine speed of sound, air column in the pipe is made to resonate with a given fork of frequency 480 Hz at room temperature T. Using a resonance tube, a student finds two resonant positions 16.6, 51.0 as lengths of the air column for the first and the second resonance respectively. It is known that the speed of the sound at room temperature 273 Kelvin is equal to 330 meters per second. Then, hold on. See, please try to understand. Please try to understand 480 meters, right? 480 Hz, right? Well, what information you are giving to me? L1 actually 16 plus end correction is lambda by 4. Similarly, 51 plus end correction is 3 lambda by 4. Now you take the difference of these two. 51 minus 16 is lambda by 2. Don't forget, this is in centimeters, right? So lambda is equal to, someone please, 51 minus 16, what is going to be? 35? 35. 35 into 2, 70 into 10 power minus 2 meter. V refers to F into lambda. Are 480 into 70 into 10 power minus 2. 48 into 7, please. 48 into 7. So that works around 48 into 7 works around. Thank you. 48 into 7 works around 336. But you said 330. So what is the percentage error? 336 minus 330 divided by 330. That works around 1.8 percentage. 1.8 percentage. But is 4 by 7 the same? No, wrong. Just please check. Is this correct? 336. Then you said 330 meter per second. Oh God, that it did not mention that the temperature is this, right? No, this is the wrong method. He did not mention the temperature where we perform is 273. This is what we got as 336. Right, thank you. Next. Okay, fine. 1 minute. Hold on. This is the temperature T. Right. How to find diameter of the tube? You find end correction in this. How to find end correction in this? 51 plus E is 3 times 16 plus 3 times E. What is 3 times 16? 48. 51 minus 48. 3. Don't forget that is again centimeters. End correction is 3 by 2 centimeters. Who cares for this? What is the formula for end correction? 0.6 R or 0.3 D. 3 by 2 into 10 power minus 2. So D is 1 minute, 1 by 10, 3 cancel. 5 into 10 power minus 2 meter or 5 centimeter. Absolutely correct. Now the velocity which you determined 336 is at T. And now you know end correction. Now you find lambda. Now you know end correction. Find lambda. 1 minute. Velocity formula is F into 2 into L2 minus L1. Agreed? Everyone, please. Delta V by V is delta L2 plus delta L1 by L2 minus L1. That is the formula. Delta L2, how do we know? 0.0, 0.0 means 2 times 0.1. L2 minus L1, you determined already L2 minus L1. What is that? L2 minus L1, 51 minus 16, 35. So this is going to be into 100 percentage. This is going to be 20 by 35. 4 by 7. Absolutely correct. Where I went is a percentage error in the measurement is what they are asking. This is correct. Now, how to find this part? V is proportional to T. So, delta V by V is half delta T by T. Delta T by T is 2 delta V by V. Already you determined it as 4 by 7 percentage. 8 by 7 percentage. Absolutely correct. The temperature of the room is nearly V proportional to root T. Right? So now in this, very comfortable zone of calculation is ABD options. C bit difficult. I'll ignore. No issues. Because my point is to score 3. If I do something wrong in C, then see, fortunately 283 is correct here. If it is a 282 and you marked 282, then you are wrong. You go -2. Right now I am at +3. Friends, I have completed the question paper. Right. Stop sharing.